Welcome to Module 5. This is where we're going to explore bias and ethics in AI systems. In this video, I'm going to cover some key topics, including types of bias, how bias manifests itself in AI outputs, some ethical frameworks for evaluation, responsible AI development practices, and the environmental impact of AI systems. Now let's explore the major types of bias in AI systems, starting with data bias, the foundation where many AI problems begin. Data bias occurs when training data, that's the data that's used to be able to develop the model, if that contains historical biases or underrepresents certain groups. So, for example, if a hiring algorithm is trained on decades of hiring data that happens to be from a company that historically hired mostly men for leadership roles, then that AI is going to learn to associate leadership with male candidates. It reflects the bias in the training data. Similarly, there are a number of studies that show that facial recognition systems that trained primarily on lighter skin faces perform really poorly on people with darker skin tones. Now, this is the most common source of bias because AI systems can only learn from the data that we give them, and human data inevitably reflects human prejudices and social inequalities from the past. Beyond data bias, there are three other critical types of bias that I wanted to highlight that all can emerge through AI development. The first is algorithmic bias. This occurs when the design of algorithms amplify existing biases. For instance, when a search algorithm consistently ranks certain types of businesses higher, or when a recommendation systems create echo chambers that reinforce existing preferences. Then there's interaction bias. This happens when user interactions with AI systems teach them problematic patterns. It's like when a chatbot learns offensive language from user conversations, or when biased user reports train content moderation systems incorrectly. And then finally, there's evaluation bias. This emerges when testing protocols fail to detect discriminatory outcomes, such as testing a medical AI only on data from one demographic group, missing how it performs on others. These biases often compound each other, creating systems that become more biased over time rather than less. What's important to remember about this is that many of these biases are reflecting biases in our own society, human biases that are reflected in the training data. They can be corrected, but without looking into it and thinking about it critically, they often aren't. Bias manifests itself in AI outputs in ways that can perpetuate and amplify societal inequalities. For instance, image generators might create stereotypical depictions when prompted with professions, showing mostly white men for CEO or scientist, while depicting nurse or teacher as predominantly female. This is what many studies have found, especially with early image generators. And then sometimes, if it's overcorrected, it might misrepresent the type of person or the category of person that would be present during certain situations. Now, text generators can produce content with subtle but harmful associations, such as resume screening tools that automatically downgrade applications that containing words that are gendered, or language models that consistently complete phrases such as the ambitious executive, and maybe they complete that sentence with male pronouns. Now, then there are recommendation systems, and these can create filter bubbles that reinforce existing preferences and biases. Political content becomes increasingly extreme, or shopping suggestions that stereotype based on perceived demographics. These outputs don't just reflect training data bias, they actively shape user perceptions and can influence real world decisions about hiring, lending, healthcare, and social interactions. There are real impacts to the presence of this bias in the training data and in the way that the AI actually works. Beyond social bias, AI systems also have significant environmental impacts that raise ethical concerns. AI systems rely heavily on data centers. Really, anything that's going into the cloud is using a data center, and AI platforms, many of them, are housed within the cloud and in data centers. And these consume enormous amounts of energy and water. According to the International Energy Agency's 2025 report, global data centers consumed between 300 and 380 terawatt hours of electricity in 2023, and they're projected to reach 945 terawatt hours by 2030, nearly tripling current consumption. AI workloads are the primary driver of this dramatic increase. Data centers also consumed approximately 560 billion liters of water in 2022 for cooling. with projections indicating that can more than double to over 1,200 billion liters by 2030 as AI systems require increasingly powerful and heat generating software hardware to be able to run the AI platforms. Now, AI data centers consume large amounts of energy and water due to high power density servers. AI GPU servers can require 50 to 120 kilowatts out per rack, up to 6 times more than traditional CPU servers that typically require 10 to 20 kilowatts per rack. So it's not entirely a unique concern for AI. If we're streaming something on Netflix or using cloud compute or doing something on the web, we're still accessing that data center. But it is found that the AI GPUs do consume a lot more energy. Now, this requires really robust cooling systems. For example, training a large AI model like GPT-3 consumed about 1,287 megawatt hours of electricity. This was the equivalent to the monthly usage of about 1,400 US households. Now, this is just in the training. When we talk about inference use and we talk about somebody actually interacting with that platform and putting a query and getting responses, that's continued use. And that's not going to be at the same rate. That's certainly much smaller because the training is done once. And then once they have the model, then it's able to be deployed. But there is continued use, especially as AI becomes more popular and used more widely in different applications. These environmental impacts have real world consequences. In water stressed regions, especially in arid locations, data centers can intensify competition for water between tech companies and local communities. According to Morgan Stanley Research, the global data center industry is projected to emit 2.5 billion metric tons of CO2 equivalent cumulatively through 2030. That's representing for the global use of data centers about 40% of what the US emits annually. Now, this poses challenges for climate goals and environmental justice, particularly as these facilities are often located in communities that are already facing environmental stressors. Responsible AI development requires several key practices that address both social and environmental concerns. Using diverse and representative training data helps prevent bias. Regular bias audits catch social issues early. Inclusive design teams bring diverse perspectives. Energy efficient algorithms and renewable energy sources reduce environmental impacts. Ongoing monitoring after deployment catches both bias and environmental issues. And transparent reporting of both social and environmental impacts can ensure stakeholder accountability. These are all part of the steps of responsible AI development, and as users, we should be aware of them and advocating for them throughout our use. There are several strategies that can reduce AI's environmental footprint while maintaining ethical development. Technological innovations like efficient cooling systems can cut power consumption significantly. Google DeepMind's AI optimization achieved a 40% reduction in cooling energy consumption at Google's data centers, and that's just the beginning of what they might be able to do in the future. Using renewable energy sources also lowers both emissions and indirect water use. Then there's model optimization techniques. These can reduce computational needs while without sacrificing performance. And as we see, as a model is deployed, very soon after, typically a few months later, they're able to find a way to be able to run it more efficiently so that won't require as many tokens, or the tokens are cheaper to deploy because they're able to do it more efficiently. Now, there's also policy transparency, which is important because it requires companies to disclose environmental impacts alongside bias reporting. And with the EU's Energy Efficiency Directive leading the way by mandating water and energy use reporting for data centers. There's also the practice of deploying on-device and edge AI models by running it on your own device, running it on your laptop or your desktop or your smartphone. You're able to use some of the AI models, but it really radically reduces reliance on energy-intensive data centers because you're processing that data locally. And I think we're going to see a lot of developments in this area as most of the devices that we're owning and we're purchasing are more powerful than they ever were before. And the models are developing in such a way they can be run more efficiently on a local device. So Apple products, of course, are talking about Apple Intelligence, and they have some models that are deployed on your devices. Google Android phones also do the same thing. This is going to really decrease the amount of energy consumption for each query, and also, of course, the water usage for cooling. This isn't going to replace being able to use something that's housed in the cloud and in data centers, but it certainly can help. Understanding AI ethics requires recognizing both social bias and environmental impacts. Ethical frameworks provide guidance for comprehensive evaluation, while responsible development practices address both bias prevention and environmental sustainability. This is just a brief overview of some of these very important topics, and I encourage you to read more about them, about how to identify and manage bias in AI, how to work on managing some of the societal and environmental risks. And as with everything related to AI, these things are moving very quickly, and they're finding more ways to be efficient, but then also more ways to use more compute. We need to be aware as users about what that means, and what the impacts might be. AI development offers many potential benefits, but we have to be sure to be thoughtful about the costs and risks as well.